In 1979, during a symposium marking the centenary of Albert Einstein's birth, physicist John Wheeler introduced a conceptual bombshell that seemed to flip the arrow of time on its head. Known as the delayed choice experiment, this thought exercise suggested a reality so radical that it remained on the fringes of imagination for decades: the idea that a conscious choice made in the present can dictate the path a particle took in the past. It is as if a film director, long after a movie has wrapped production, could reach back into the footage and alter the protagonist's opening scene. The setup for such a profound revelation is deceptively simple, involving a labyrinth of beam splitters and detectors. When a photon enters this apparatus, it faces a classic quantum crossroads. It can either behave like a solid particle, traveling down one specific route, or behave like a wave, exploring every possible path simultaneously. Traditional intuition suggests that the photon makes this choice the moment it enters the device. However, Wheeler's genius was to delay the decision. By waiting until the photon has nearly completed its journey before deciding whether or not to insert a second beam splitter, researchers have discovered a glitch in the matrix of spacetime. When the second piece of glass is absent, detectors record the photon as a single particle following one clear path. Yet, if the glass is inserted at the very last microsecond, interference patterns emerge on the screen, proving that the photon had been traveling as a wave through all paths from the very beginning. The staggering implication is that the current choice to insert the glass forces the photon to have always been a wave, even though it passed the initial entry point long before the choice was made. It is akin to an archaeologist brushing dust off a fossil and finding that their specific cleaning technique physically changes how the dinosaur lived millions of years ago. Since the 1980s, real-world experiments have moved these ideas from the chalkboard to the laboratory. From Carol Alley's team using lasers reflected off the moon in 1984 to Vincent Jacques' validation of quantum interference in 2007, the results have consistently confirmed this counterintuitive truth. There is no pre-written script for the quantum world. Instead, the observer acts as the ultimate editor of history. Pushing the boundaries even further, researchers at Nanjing University achieved a breakthrough in 2019 that earned a place among the top 10 developments in Chinese optics. By precisely controlling multiphoton entanglement, they created a state where a photon could exist in a controllable superposition of both wave and particle identities simultaneously. This allowed scientists not just to choose a history, but to bridge the gap between two different types of reality, opening new vistas for the future of quantum computing. These findings shake the two pillars of classical physics, the law of cause and effect and the concept of objective reality. In the quantum realm, causality collapses because the effect can seemingly precede the cause. Furthermore, the idea of an objective world existing independent of us is brought into question. Without an observation, a quantum system is like unexposed film, a blur of every possible image existing at once. This perspective has led modern cosmologists, including the late Stephen Hawking, to propose a top-down view of the universe. They suggest that the history of the cosmos itself may not be a single, fixed line. Instead, the universe may have existed in a massive superposition of countless versions since the Big Bang, 14 billion years ago. It was only when the first observation or conscious interaction occurred that these possibilities collapsed into the specific reality we inhabit today. In this view, our scientific inquiries act like keywords in a cosmic search engine, pulling a specific history out of a vast database of parallel multiverses. As we stare at the flickering interference patterns in modern labs, we are reminded of Wheeler's philosophical mantra: no fundamental quantum phenomenon is a phenomenon until it is a recorded phenomenon. We are not merely spectators in a clockwork universe, we are active participants, co-writing the deepest script of existence with every look we take.